in two-step experiments, or called two-stage experiment. So the sample space for a two-stage experiment can be displayed by using tree diagram or a table. Okay, today we talk about the table first. Well, what is two-stage experiment? Is you do something twice. You have two actions. Okay, you have two actions basically. Well, I can observe one thing, record the result. I can observe another thing and then record the results. Okay, that's a two-step or two-stage experiment. So like toss the coin twice is the two-stage experiment. The first time I can observe whether it's a head or a tail. The second time I can observe whether it's a head or a tail. I have like two outcomes, okay, and then that's make together as a one outcome. Or I can say I toss a coin at the first time, record down whether it's a head or a tail. And then the second time I can throw a dice and I record the number, whether it's 1, 2, 3, 4, 5, 6. Okay, that is a two-stage experiment as well. So two-stage is basically I observe twice and I have two actions. Okay, I have two actions. So using like the tree diagram can work for two or more stages. But for the table, only work for two stage. Okay, so the table only work for two stage, but the tree diagram can be used for two or more. It can be 3 stage, 4 stage, okay, it can be 2 or more stages. Okay, why only the table can only work for two stage? Because you only have row and column that can only represent two things. Okay, can only represent two things. Okay, and then the second thing we need to understand is whether it's a with replacement or a without replacement question. Like say the nature of throw dice will be with replacement, because what you should think about is like if I get the number 1 first, can I get it for the second time as well? If you can get it for the second time, yes, there is a with replacement question. How was it without replacement question? Let's say you select a candy from a box and you eat it and you want to select another one. Can you select the identical one? No, you can't. Okay, you eat that already, you can't select another time. Then that's a without replacement question. Some question, the nature will be with replacement or without replacement without stating that. Okay, so for example, like I used up something. That's definitely without replacement. Like you select it and use it, you can't go replace that. And let's think about if you select 5 people in a committee, like for the school. Do you think that's a with replacement or without replacement question? You want to select 5 people to form a committee. Without, okay, if you select me, okay, as one of the person, you can't select me again for the second time because I'm not going to be 2 people like in the committee. I can only be included once. You select me and you put me away, okay, that's out of the sample space already, like I'll go out. And then you select another one. That will be a without replacement question. So see, this question doesn't say with replacement or without replacement. I just say select 5 people to be in the committee. Then you will decide whether it's with or without replacement. Okay, so let's think about number 1. Select 2 people to play in a team. Do you think that's a with or without? Without. You can't have same person play with himself. So it's a without replacement. Tossing a coin twice. Do you think that's a with replacement or without replacement? With. Okay, you can get the same outcome twice. If you get a head for the first time, this outcome still can appear in the second experiment. So that's a with replacement. Rolling 2 dice. With or without?
With replacement.
With replacement. Choosing 2 chocolate to eat.
Yeah.
Without. You can't eat the same chocolate twice. Okay, that's example 1. Example 2 is a question without replacement. Okay, that's a question without replacement. So, if that's a question without replacement, I think you learned this in year 9. So, you can treat the row as the first selection, or you can treat the column as the first selection. It doesn't matter, okay? But you just need to decide which is your first selection, and then you use it all the time. You can't say, oh, for the first row, the row will be my first selection, and for the second row, the column will become my second selection. That's not correct. So which one is the first? You write down, okay, that's my first. That's always my first. So how you can write down? I will decide to say the column will be my first selection. I'll just draw a line here to say like first and second selection. And because it's a without replacement, okay, two letters are chosen from the word K-I-C-K, kick, without replacement. Construct a table to list the sample space. Okay, because without replacement, so the table will be a little bit different. So if the first selection already select the first K, then the second one can't have the K at all. If you select the I can't work at all. If you select C can't work for the third one, and then the K can't work for the last one. So the diagonal will have cross, okay? You can't have those placed with a letter because you can't select K and K twice, I and I twice. Even though you have two K, it's possible to get a K for the first time and get another K for the second time, but it's not the same K, okay? It's not like, say, you write that on a piece of card, okay? It's not going to be the same card, all right? Alright, so how do we label the sample space? If we select a K for the first time and then we go to look at the row, what's the second? Okay, the second, like the first one you write K and second one you write I. That's my outcome. That's one of my outcome. In the bracket with a comma in between means the order. Okay, K is the first one, I is the second one. If you write K, comma, I, which means K is the first and I is the second, it's with the order, okay, with the order. And then I can say that's a KC and KK. For the second one, I select I first. I can have IK, I can have IC, and I have IK again. For the third one, I have CK, I have CI, and I have CK. For the last one, I have KK, KI, and KC. Okay, so what's the total number of outcomes? Let's say the number, I'll use a symbol to represent that. That's the number of the sample space, the universal set. Okay, that's the universal set. How many elements are there in the universal set? How many? How many brackets you have? Right. 12. Okay, 12. So the total number of outcomes will be 12. The cross you have on the diagonal, that's not counting. Okay, you can't have them. You definitely have nothing related to them. So you have 12 outcomes in total. So obtaining the outcome KC. Okay, if obtaining KC must represent that the first is K, second is C. Okay, CK is not working. Must be in the particular order, KC. Okay, KC. So if you're looking for KC, I can have a KC here, I have a KC here. I have two KCs. So the probability of getting KC equals to 2 on 12, and that's 1 on 6. Okay, probability of KC is 2 on 12 and it's 1 on 6. The total number of the events, okay, the events I'm interested in, that's the event KC. There are 2 outcomes, okay, number of cases 2, and then over the number of total, which is 12. Next one, selecting 2 Ks. Well, if it's selecting 2K, it doesn't matter which one is the first, which one is the second. So just KK. It's 2 on 12 as well. Okay, in the first row and last row, you have KK. So it's a 1 on 6 as well. Number 3 is talking about selecting a K and a C. Okay, if it's selecting a K and a C, it can be K and C first, or union C and K as well. The order doesn't important in this question. I can have KC, I can have CK. It doesn't important at all. It doesn't give the order in the question. So I just need a C and a K in my hand in the end. So I don't care about the order. So it's KC and CK. That equals to, okay, let's have a look. KC, I have 1 and 2, and CK, I have 1 and 2 as well. So it's a 4 on 12, which is a third. Okay, which is a third. 4 on 12, that equals to a third. Okay, that's question without replacement. If it's without replacement, what you need to do is on the main diagonal, you will have all the cross. Okay, I have all this cross. Okay, for the next one is a naturally with replacement question. Okay, so with replacement question. Because a 6-side die is toasting twice, you're trying to toast the dice twice. So the first time you get 1, the second time you still can get a 1. So I will write like a line here, and I will say that's the first and that's the second. Okay, the first and the second. Well, if the column is the first, I will have 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5, and 1, 6. And if I have, like I read a column that is 2, 2, 3, 2, 4, 2, 5, 2, and 6, 2, because the row is the first one. The column is the first one, the row is the second one. That's just my way, okay? You can have row as the first, column as the second, doesn't matter. But I'm not going to write all of it, it's just waste of time. What's the total number of outcomes? 36. Okay, I have another question. Let's say I'm not having like a 6-side die. Let's make the question easier, okay? Think about we have 4-side die, okay? I have 1, 2, 3, 4, 4 sides. I have 1, 2, 3, 4 at equal likely events. Now what I have is, again, this table can only work for equal likely events as well, okay? Better to mention that at the beginning. So equal likely only as well. This cannot have like not equal likely events. If it's not equal likely, you're not going to use this method. Okay, if my question is, let's say Lily is trying to throw the 4-side die twice and find the sum of it, okay? Find the sum of the 2 numbers. I want to know what is the sum of this number. How you can set up this table? What's the difference between the table compared to this one and the other one? If I'm interested in the sum of the 2 numbers, what I need to have, like, is the table, well, okay, let's say 1, 2, 3, 4. 1, 2, 3, 4. That's the 4-side dice, and it's equal likely. I'll say that's the first, that's the second. But in the box, you are not going to write 1, 1, 1, 2. What you need to write instead is the sum of the numbers. 2, 3, 4, 5. 3, 4, 5, 6. 4, 5, 6, 7. 5, 6, 7, 8. That will be your outcome. Your outcome is not the list of number anymore because I'm interested in the sum of two numbers. And then you need to do the sum of two numbers. No. Okay? So use the two add together. So that will be the table, what the table looks like. If I'm doing throw the dice twice, the 4-side dice twice, and then I want to add the number, that will be my total, that will be my table. If I say use the first one to subtract the second one, okay, if you say use the first one to subtract the second one, what I should have here is, okay, that's the first, subtract the second, 0, 1, 2, 3, minus 1, 0, 1, 2, minus 2, minus 1, 0, 1, minus 3, minus 2, minus 1, 0. Okay, if you use the first to subtract the second, that's what you're going to have. If I say just use the larger number to subtract the smaller number, then you just have positive, 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 and positive. Alright, so it according to what the people trying to do, okay, what trying to see in the end, then you will set up your table in that way. Okay, if I say the sum of it, you just add them. The difference between them, you subtract from them. And you say the first one subtract the second one, you will have the minus. Okay, so that's the table. The table will be set up and the outcomes will be written in the way that the question asks. Okay, the question wants. If I want the sum, I need to write the sum. Okay, let's come back to this question here. So the total number of outcomes is 36. Find the probability of obtaining 1 and 5. How many outcomes will be 1 and 5? 1 only. Okay, the first one is 1, second one is 5. There's only one situation like that. So it's 1 on 36. I'll say probability 1, 5 equals to 1 on 36. Because there's one of that outcomes over the total number of 36. Okay, the probability of double. What do you think the probability of double will be? How many double you have? 6. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 6 on 36. That is a 1 on 6. Okay, that is a 1 on 6. Okay, sum at least 10. Okay, sum at least 10. Okay, if I want at least 10. Okay, I will just label it like here. I need 6 and I need at least 4. Need 5. Okay, how can I label it? If the first one is 1, not going to have. 2, not going to have. At least 4, I will start to have it. I think it's those box who got at least 10. Have a think, is that correct? Those ones will be at least 10. So 4, if the first one is a 4, I will have 6. 5, 5, 6. 6, 4, 5, 6. So there are 1, 2, 3, 4, 5, 6. 6 outcomes like that. So that equals to 6 over 36 is 1 on 6. Okay, the last one is asking the equal is not 7. What you should do to that? Sorry? Count all the ones give you 7 and then use 1 to subtract. Okay, you're not going to count how many not give you 7. Okay, it's too many. So if you just want 7, what I'll have is 1 and 6 give me 7. 5 and 2 give me 7, 3 and 4 give me 7, 4 and 3 give me 7, that give me 7, and that give me 7. So it's a diagonal. 6 1 2 5 3 4 4 3 5 2 6 1. Okay, these ones give me a 7. So that's 1 2 3 4 5 6 outcomes. So that's 1 minus the probability sum equals to 7. And that is 1 minus 6 over 36. That is 5 on 6. Equals to 7. 1 6 2 5 3 4 4 3 5 2 6 1. Okay, those ones give you 7. So it's a 6 on 36 give you 7. And then 1 minus that is not give you 7. It's like the complementary set. Okay, it's the complementary set. That's a width replacement question. Okay, if it's a width replacement question, two-stage equal likely, then every box will be filled in. Okay, every box will be filled in. Okay, have a look at example 4. Okay, have a look at example 4. Read example 4 first and find your own way to do it. Okay, try one way of doing this question. Well, if you're familiar with tree diagram, you can use tree diagram. This question I will show you the table method because I'm teaching table today. If you feel like you can directly work it out by equations, then you can directly work out by equations. All depends on you. Okay, so just find a way of doing that. Okay, there are 5 people participating in an event. 2 awards will be given to 2 people randomly. Cannot give 2 awards to the same person. What is the probability that person A will win one of the awards? Okay, so the fact of this question is, I don't care who's person A. Person A, person B, person C, person D, person E will all get the same probability of like getting this award, or like 1 award at least, 1 at most. Okay, so it's either not having the awards or having one of it. Well, if I use a table method, okay, if I use a table method, what I will have is if I set up a table like that, and there's 5 people, I'll say I have A, B, C, D, and E. Okay, and A, B, C, D, and E. 5 person here. Okay, that's the column is the first award is given to whom, and the row is the second award is given to whom. Okay, I set up the table in that way. And you know that 2 awards can't given to the same person. I'm not going to have this box because not get A, B, B, C, C, D, D, E. So what I will have is, for the first one, I'll get A, B, A, C, A, D, and A, E. That's the first, like, awards is given to A, and second, I don't care who gives to whom. And the second one is BA, BC, BD, and BCA. That's a CA, that's a DA, and that's a EA. Okay, that's the second award is given to the first person. Okay, second award is given to A. And I have the other, like, I don't know, I'm not going to fill in all the rest, but the number of total will be 20. Okay, each row got 4 outcomes. There are 5 rows. I will have 20 is the total. So the probability of A getting awards, like one of the award, will equals to, okay, what I have right is A either get the first award or the second award. 1, 2, 3, 4, 5, 6, 7, 8 is 8 over 20. And that is a 2 on 5. Okay, that is a 2 on 5. That's complete by using this table. Okay, this is a selection of people and without replacement question. Okay, select people and without replacement question. Okay, so A is getting select for the first time, or A is getting select for the second time. Okay, what I will have is like going through another method with you. That's a little bit hard, but have a think about that. Okay, A gets awards will be the same as probability. Get first one, not second one, plus the probability, not first, but second. Okay, so it can be 2 situations. You either get the first award but not the second, times plus the probability you get the second but not the first. Okay, so this probability will equals to get the first one. There are 5 people at the beginning. Okay, a group of 5 there. You are one of them. Randomly pick one student and you are the one get picked. That's 1 on 5. That's 1 on 5. And for the second awards, I don't want to give that awards to you. That probability is a 1 because definitely you are outside the door. You are not gonna get selected for the second time. So that is a 1. So it's getting the first one intersects getting the not getting the second one. So get the first one is 1 on 5 because 5 people in a room. I select one to put outside the door. That's 1 on 5. And then you're already outside the door. You won't get picked another time. So that's definitely 1 not getting the second. So it's a 1 on 5 times 1 plus. Okay, not get the first one. Not get the first one is a 4 on 5. I'm not going to have it. Okay, there are 5 people here. There are 4, like, unless select me, otherwise I get a 4 on 5 of the probability, can't get it. Okay, then someone is thrown outside the door already. Okay, left 4 in the room, including me. Okay, including me. Then I want to get the second one. I want to get the second one. That's a quarter. Okay, can you think about that? That's a quarter. Because 5, okay, outside 1. 4 left in the room. I'm the one. I won't get selected. It's a 1 on 4 for the second time to get the award. So that's a 1 on 5 plus 1 on 5. That's a 2/5. Okay, that's a 2/5. Okay, so that's a way not using any method to help me. Like I just purely think about what could happen and find the probability. Alright. So I have finished this exercise. I have 2 more exercises to go for the probability chapter. So you can do some homework now. You need to catch up. So today we up to 8E. Okay, 8E. We have 8F and 8G left.